Dear students, welcome back to math class. In the last class we have discussed if we join the ends of a diameter of a circle to a point on the circle, then we get a right triangle. Today we are going to discuss just reverse of the last result. What is that? Listen. If we draw mutually perpendicular lines from a point on a circle and join the points where they cut the circle, do we get a diameter? Okay. In the last class we have discussed if we join the ends of a diameter to a circle or to a point on a circle, then we get a right angle. Here just reverse. If we draw mutually perpendicular lines from a point on a circle and join the points where they cut the circle, do we get a diameter? Okay. So first let us check. Here 90 degree. Now we can say that these two lines are perpendicular. Okay. Now let us join the ends of these angle. Okay. What we get? Yes, we get a right triangle. Now listen. All vertices of this triangle are on the circle. So we can say that this circle is a circumcircle. We have studied in 9th standard. If all vertices of a triangle on the circle, then the circle is a circumcircle. And also this triangle is a right triangle. Now we have discussed in 9th standard. What is that? The circumcircle or the circumcenter of a circumcircle is the midpoint of the right triangle. Okay. If we draw a circumcircle to the triangle, then the circumcenter is the midpoint of the hypotenuse of the triangle. Okay. So this is the diameter or the hypotenuse of the triangle, then the circumcenter is the midpoint of this hypotenuse. Okay. And also we can say that this hypotenuse is the diameter. Okay. The circumcenter of a right triangle is the midpoint of the hypotenuse. We have discussed in 9th standard. So the line is a diameter. Okay. So if we draw mutually perpendicular lines from a point on a circle and join the points where they cut the circle, then we get a diameter. Okay. Next, we have learned in class 9th to locate the center of a circle. Did you remember that? Yes, by drawing perpendicular bisectors of chords to locate the center of a circle using a bangle or a lid. Did you remember that? Okay, we drew that figure. Next, here is another way to locate the center of a circle. How? All of you listen. First, draw a circle. The next, draw perpendicular lines. Let us join them. Similarly, we can draw one more right triangle. Just to change the position of the vertex. So we have drawn two right triangles and we got one intersecting point here. Okay, this is our center of the circle, or we can draw circle using this point as center. Okay, this is the method of drawing circle, or to locate the center of a circle by using our set square. Okay, next question. Suppose we draw a circle with the bottom side of the triangles in the picture as diameter. Find out whether the top corner of each triangle is inside the circle, on the circle, or outside the circle. Here you have given three triangles. Then the top angles are 100 degree, 90 degree, 70 degree. Then what is our question? Suppose we draw a circle with the bottom side of the triangles. This is the bottom side of the three triangles in the picture as diameter. Find out whether the top corner of each triangle is inside the circle, on the circle, or outside the circle. So just let us name this AB. Then this vertex is C, the next D and E. Now can you say the positions of angle E, D and C? If we draw a circle with AB as diameter, angle E. Where is angle E? On the circle or inside or outside? Can you say? Angle E is inside the circle. What is the reason? 100 is larger than 90 degree. Angle E is inside the circle. Angle E is inside the circle. Reason? 100 degrees is greater than 90 degree. Okay. If we join the ends of a diameter outside the circle, then we get an angle, inside the circle, then we get an angle larger than 90 degree. The next, angle D. The measure of angle D is 90 degree. So where is the position? Angle D is on the circle. On the circle. Reason? The measure of angle D is 90 degree. If we join the ends of a diameter to a circle or to a point on a circle, then we get a right angle. The next, angle C. Angle C is outside the circle. Why? 70 degrees is less than 90 degree. Okay. So, angle E is inside the circle, angle D is on the circle, and angle C is outside the circle. Angle C is outside the circle, angle D on the circle, and angle E is inside the circle. Okay, can you understand? Yes. Next question. For each diagonal of the quadrilateral shown, check whether the other two corners are inside, on or outside the circle with that diagonal as diameter. Okay. You have given one quadrilateral and also three angles, 105 degrees, 55 degrees, 110 degrees. Can you say what is the fourth angle? Fourth angle is, how we can find out? The sum of the four angles of a quadrilateral is 360 degree. Sum of the angles of a quadrilateral is 360 degree. So, let us name the quadrilateral A, B, C and D. Okay. Now, angle D is 360 minus 105 plus 55 plus 110. That is 360 minus, what is the sum inside this bracket? 105 plus 55 plus 110. 105 plus 55, 160 plus 110, 270. 270. So, angle D is 90 degree. Now, the measure of angle D is 90. Okay. Now, what is our question? For each diagonal of the quadrilateral shown, check whether the other two corners are inside or on or outside the circle with that diagonal as diameter. So, first let us draw this diagonal. Diagonal AC. What about the other corners or other vertices? Angle B and angle D. If we draw, question, for each diagonal of the quadrilateral shown, check whether the other two corners are inside, on or outside the circle with that diagonal as diameter. So, if we draw AC as diameter of the circle. Okay, AC is the diagonal of this quadrilateral. So, if we draw AC as the diameter of the circle, then angle B is, where is the position of angle B? This is less than 90 degree. So, angle B is outside the circle. Angle B is outside the circle. Is 55 degrees less than 90 degrees. Okay. The next angle D. What about angle D? Angle D is on the circle. Angle D is on the circle. Reason? Yes. We have angle D is 90 degree. If we join the ends of a diameter of a circle to a point on the circle, then we get a right angle. So, angle D is on the circle because angle D is 90 degree. Okay. If we draw AC as the diagonal and also this is the diameter, then angle B is outside the circle and angle D is on the circle. Okay. Next, draw one diagonal BD. Diagonal BD. Now, we have to find out the positions of angle A and angle C, or the vertex angle A and the vertex angle C. Okay. Angle A is 105 degree, which is larger than 90 degree. Now can you say where is angle A? Angle A is inside the circle. What is the reason? 105 degrees is larger than 90 degree. Angle A is inside the circle. Inside the circle. When if we draw a circle with BD as diameter, okay, or the diagonal BD as diameter, the position or angle A or the vertex A is inside the circle because 105 degrees is larger than 90 degree. The next angle C. Angle C is also inside the circle. Inside the circle. Okay. Angle C is also inside the circle. Why? This is larger than 90 degrees. 110 is larger than 90 degree. If we join the ends of a diameter of a circle inside the circle, then we get an angle larger than 90 degree or larger than a right angle. Okay. So angle A is inside the circle and angle C is also inside the circle. Okay. Can you understand? Okay, let us wind up the class. Thank you. Have a nice day.